first of all, I would like to thank Jean for organizing the event and giving me a chance to be part of it. Today, I want to talk about Power BI internals and share with you some best practices to keep your data model size in optimal condition. I believe it's quite important topic from many perspectives. Therefore, I really hope that you will enjoy the session and get some useful takeaways once we are done. Before we start, I will just briefly introduce myself. My name is Nikola Ilic. I'm originally from Belgrade in Serbia, but for the last 5 years, I live in a wonderful city of Salzburg in Austria, where I work as a business intelligence developer. Living in Salzburg was the reason why I've chosen my nickname Data Mozart. As you probably know, Salzburg is worldly famous as a birthplace of Wolfgang Amadeus Mozart, so I was brave enough to use his last name as part of my nickname. And that's why my motto is make music from your data. You can find me on web. I'm regularly blogging at data-mozart.com. I'm also pretty active on LinkedIn and Twitter, so feel free to connect if you like. A few more sentences about me. I have multiple year experience working with different data products, predominantly Microsoft Data Platform. Started with SQL Server, then continue with analysis services, multidimensional, SQL Server reporting services, integration services, and most recently, if you consider last 4 years as recent with Power BI. I'm also a Microsoft Data Platform MVP and Microsoft Certified Trainer and also a plural site author. Privately, I'm father of 2 kids and true football and Barca fan, as you can conclude looking at the photo on your screens. So what should you expect today from this session? Well, I like to tell stories. So don't expect a classic session today. I want to tell you kind of a story about a wonderful tool called Power BI. And in my story, you will be a real hero and our villain is the non-optimal data model size. As in most stories, we will fight, but heroes win in the end. So you will see how to overcome challenges brought to us by the evil data model, resolve different issues along the road, and finally make your Power BI development a real fairy tale. Therefore, make yourself comfortable, take a seat, grab a coffee or some other refreshment, and listen carefully to my story. So I guess you all know the story about Titanic. If you don't know, you should watch the movie with Leonardo DiCaprio and Kate Winslet. Wait, what? Yeah, you've already watched it, sure. Who hasn't? So Titanic was the most powerful, most beautiful, the largest ship of all time. But Titanic's story ended almost before it started. And after only 4 days of voyage from Southampton to New York City, in the early morning hours in April 1912, the Titanic hardly hit one of the many icebergs in the Atlantic Ocean. At first look, it didn't seem like something that can transform the greatest engineering achievement into a historical tragedy where more than 1,500 people lost their lives. However, Titanic didn't sink because it hit the tip of an iceberg. The main culprit was under the surface in the cold ocean water where the largest part of this iceberg resided. Titanic received the shot without a chance to recover, and less than 3 hours later it was on its way to the ocean's bottom and placed in many books and movies as well. Now you're probably asking yourselves, what is this man talking about? What on earth story of Titanic has with Power BI? But if we think a little deeper, we can think of Power BI as an iceberg in the cold ocean's water. The tip of an iceberg is your Power BI dashboard or the report itself. And yeah, I'm sure you will admit that it looks beautiful, like a snowy mountain straight in the middle of the water. But the real thing is under the surface. This biggest and strongest part of the iceberg, which provides stability and steadiness of this visible part. And this underneath part consists of multiple individual but cohesive parts which enable this part above the surface to stand strong and shine. As I said, there are multiple individual portions down there. If you think for a moment here as a Power BI developer, you will see different concepts, architectures, and techniques that make your Power BI dashboard shine. For example, if you don't understand and apply those concepts on the right, such as data profiling, data modeling, and data shaping in a proper way, your Power BI report will probably experience the same fate as Titanic. Same applies if you don't dedicate deserved attention to architectures and techniques on the left. Always keep in mind that all these, but also many more core concepts are what enable your Power BI dashboards to perform in the most optimal way. Therefore, never underestimate the importance of understanding all those invisible things under the surface. Today, we will focus on learning and understanding the Vertipack engine, but you should also spend your time learning other key concepts listed here. In the end, you can create Power BI reports that work without knowing these underlying concepts at all. But there is a huge difference between Power BI reports that just work and Power BI reports that work efficiently. Now, in order to follow the story or watch the movie, you need to have some skills before you start. For example, you can't read the book in Chinese if you don't know Chinese. So we are talking about prerequisites. And in regard to this session prerequisites, I need to stress a few things. First, this is a 300 level session, which means advanced level. So it assumes that you have some, not just basic, but intermediate knowledge and experience with Power BI and data modeling in general. That being said, I expect from you to have at least basic understanding about relational databases, their structure, in terms of how data is being stored in the database, and to be able, of course, to distinguish between rows and columns. Of course, knowledge of Power BI is also necessary to follow along, as I will often refer to some things related to a Power BI development that I assume you're familiar with. So as we agreed that I'm telling you a story, I mean, we didn't agree, but I hope that you're fine with that. I've intentionally avoided call this part agenda. Instead, let's think of it as contents of the book. So what's in for you today? We will learn what is Vertipack, how it stores the data, what kind of algorithms Vertipack applies to compress the data, and how we can help Vertipack to build an optimal data model for us. Finally, we will need to leave our book on the shelf shortly, pick our toolboxes, go out, get our hands a little dirty, and dig deep under the hood of Power BI. During the demo, I will show you a real-life example, how I managed to reduce Power BI data model size by a whopping 90%, just by sticking with a few basic but extremely important rules that we will talk about today. Okay, here we are. Once upon a time in a far, far away land. Just kidding, my story doesn't start like that. My story starts with a simple question. Have you ever wondered what makes Power BI so fast and powerful when it comes to performance? And when I say powerful, I mean that it's able to perform complex calculations over millions or even billions of rows in a blink of an eye. Maybe you wondered but couldn't find a proper answer. Perhaps you were just seeing the tip of an iceberg. So today we will discover what is under the surface of Power BI, how your data is being stored, compressed, queried, and finally brought back to your report. And once we are done, I hope that you will get a better understanding of the hard work which is happening in the background and appreciate the importance of creating an optimal data model in order to get maximum performance from the Power BI engine. So going back to our starting point, what is a Vertipack? Again, you will need to wait for an answer. Before we come to it, we should mark the line between row store versus columnar databases. A Vertipack is a columnar database. As you can see in this illustration, columnar databases store and compress data in a whole different to traditional row store databases. Columnar databases are usually implemented in large analytical systems as they are optimized for vertical data scanning. This means that every column has its own structure and is physically separated from other columns. Another important distinction in order to understand what is Vertipack is to understand the difference between formula engine and storage engine. As you can see in this illustration taken from the book Definitive Guide to DAX from Marco Russo and Alberto Ferrari, this is the simplistic version of how this engine looks like. Basically, Formula Engine accepts the request, processes it, and generates the query plan before it finally executes it. Storage Engine pulls the data out of the tabular model to satisfy the request issued within the query generated by the Formula Engine. Storage Engine can work in two different ways in order to retrieve requested data. Vertipack, which will be the highlight of our today's talk, so this part here. Vertipack keeps the snapshot of the data in memory, and this data snapshot can be refreshed from time to time from the original data source. As I said, today we will talk about this part of architecture. On the other hand, direct query doesn't store any data. It just forwards the query straight to the data source for every single request. We will also talk about direct query today, but without going deep into details. Okay, so let's talk about Formula Engine. Formula Engine represents the brain of Power BI. As I already stressed, Formula Engine accepts the query, and since it's able to understand DEX and MDX, by the way, but it is out of the scope of this session, it translates DEX into specific query plan, and that query plan consists of different physical operations that need to be executed in order to get results back. Those physical operations can be joins between multiple tables, aggregations, filtering conditions, and so on. It's important to know that Formula Engine works in a single-threaded way, which means that requests to storage engine are always being sent sequentially. So let's go and reiterate once more through the whole process that is happening within the Formula Engine. The first step is that Formula Engine accepts the request, then it processes this request. Next in the line is generation of the query plan, and finally it executes the generated query. Once the query has been generated and executed by the Formula Engine, then storage engine comes into the scene. And as it physically goes through the data stored within the tabular model, which is Vertipack, or goes directly to a different data source, like SQL Server, for example, if you're using direct query storage mode, we can think of storage engine as the muscles of Power BI. When it comes to specifying the storage engine for the table, there are three possible options to choose from. These three options are import mode, direct query mode, and dual mode. We will talk about each of those options in a few minutes. As opposed to Formula Engine that doesn't support parallelism, storage engine can work asynchronously. So let's first briefly introduce import mode, which is the most common way to store the data when working with Power BI. And that said, import mode is based on Vertipack. Table data is being stored in memory as a snapshot, and this snapshot can be refreshed periodically. How often, how frequently it will be, that depends on your specific business needs. It can be once per day, once per hour, every half an hour, and so on. When you're using direct query storage mode, data is being retrieved from the data source at the query time. And that means that data resides in its original source before, during, and after the query execution. Finally, dual mode represents a combination of the previous two options, import mode and direct query mode. Data from the table is being loaded into memory, but at the query time, it can be also retrieved from the data source. Okay, so as we have drawn a big picture previously, let me explain in more detail what Vertipack does in the background to boost the performance of our Power BI reports. When we choose import mode for our Power BI tables, Vertipack will perform the following actions. So it will first read the data source and transform the data into a columnar structure. Then it will encode and compress data within each of those columns. After that, it will establish a dictionary and index for each of the columns. Next, it will prepare and establish relationships. And finally, it will compute all calculated columns and calculated tables and compress them. As you may recall from the previous part of our session, two main characteristics of Vertipack are that Vertipack is a columnar in-memory database. So Vertipack applies different types of compression to each of the columns independently, choosing the optimal compression algorithm based on the values in that specific column. That's important to keep in mind. Compression is being achieved by encoding the values within the specific column. But before we dive deeper into a detailed overview of different encoding techniques, just keep in mind that this architecture is not exclusively related to Power BI. In the background is a tabular model which also works under the hood of Analysis Services Tabular and Excel Power Pivot. So let's now examine the encoding types which Vertipack applies in order to compress the data. There are three of them. So first one is a value encoding, then hash encoding or dictionary encoding, and finally RLE, which is abbreviation of run length encoding types. Now we will go into more detail regarding each of these three types, and let's start with value encoding. This is the most desirable encoding type since it works exclusively with integers and therefore require less memory than, for example, when working with text values. How does this look in reality? Let's say we have a column containing a number of phone calls per day, and the value in this column fluctuates between 4,000 and 5,000. What the Vertipack would do is to find the minimum value in this range, which is 4,000 in our example, and set this minimum value as a starting point. Then it will go and calculate the difference between this value and all the other values in the column and store this difference as a new value. Looking at this example, you see that we managed to save 3 bits per one row, and at first glance 3 bits might not look like a significant saving, but just imagine that you have millions or I don't know, even billions of rows in this table, then multiply this with 3 bits per row, and I think you will appreciate the amount of memory saved using value encoding. Next is hash encoding. This is probably the most used compression type by Vertipack. Using hash encoding, Vertipack basically creates a dictionary of distinct values within one column and afterward replaces real values with index values from the dictionary. Let me show you an example. It will be much more clear. As you may notice, Vertipack identified distinct values within the subjects column. So here, okay, and assign index values to each of those distinct values. Then it built a dictionary by assigning indexes to those values and finally stored index values as pointers to real values. And I assume that you are aware that integer values require way less memory space than text. So that's the logic behind this type of data compression. Additionally, by being able to build a dictionary for literally any data type, we can say that Vertipack is practically data type independent. And this brings us to a very important takeaway from this session. No matter if your column is of text, float, or big integer data type, from Vertipack perspective, it's the same. So in each of those scenarios, Vertipack will create a dictionary for the column, which implies that all these columns will provide exactly the same performance, both in terms of speed and memory space allocated. Of course, if we assume that there is no big difference between dictionary sizes between those columns. So it's a myth that the data type of the column affects its size within the data model. On the opposite, the number of distinct values within the column, which is known as cardinality, mostly influence column memory consumption. Okay, the third algorithm, RLE or run length encoding, creates a kind of a mapping table containing ranges of repeating values and that way avoiding to store every single repeated value separately. Again, take a look at the example and that will help to better understand this concept. In real life, Vertipack will not store this start values here. This is just for the sake of clarity here. So because it can quickly calculate where the next node begins just by summing all the previous values here. Okay, so let me just move. Fine. So as powerful as it might look at first sight, run length encoding algorithm is highly dependent on the ordering within the column. If the data is stored the way you see in our example, run length encoding will perform great because we have a buckets of repeating data. So this is one data with many repeating values. This is the new value with repeating values. But if your data buckets are smaller and rotate more frequently, then run length encoding would not be an optimal solution. And one more important thing to keep in mind regarding run length encoding, in reality, Vertipack doesn't store the data the way it is shown in this illustration. So first, it performs hash encoding and creates a table of distinct values, and then apply run length encoding algorithm on top of it. So the final logic, of course, in its most simplified way, would be something like this illustration you can see on your screens. So basically, run length encoding occurs after hash encoding in those scenarios when Vertipack thinks that it makes sense to additionally compress data. So when the data is ordered in that way, that run length encoding algorithm would achieve better compression than hash encoding solely. Okay, so let me just briefly iterate through the process of data compression for a specific column, or the process of how Vertipack thinks. So first step is that Vertipack will scan sample of rows from the column, and if the column data type is not an integer, it will look no further and it will use hash encoding. If the column is of integer data type, some additional parameters are being evaluated. If the numbers in that sample linearly increase, Vertipack will assume that it is probably a primary key and it will choose value encoding type. If the numbers in the column, in integer column, are reasonably close to each other, so the number range is not very wide, like in our example with 4,000 to 5,000 phone calls per day, Vertipack will use value encoding. On the other hand, when values fluctuate significantly within this range, for example, between 1,000 and 1 million, then value encoding would not make sense and Vertipack will apply the hash algorithm instead. However, and this is important, no matter how smart Vertipack is, it can happen that it makes some bad decisions sometimes based on incorrect assumptions. And it can happen that Vertipack makes a decision about which algorithm to use based on the sample data, but then some outlier pops up and it needs to re-encode the column from scratch. Let's use our previous example for the number of phone calls, and let's imagine that Vertipack scanned the sample and choose to apply value encoding. Then after processing 10 million rows, all of a sudden it found a 500,000 value. It can be an error or whatever. And now what Vertipack would do, it will reevaluate the choice and it can decide to re-encode the column using the hash algorithm instead. And that would obviously impact the whole process in terms of time needed for reprocessing. Here is the list of parameters in order of importance that Vertipack considers when choosing which algorithm to use. First, as already mentioned, is number of distinct values in the column, which is known as cardinality. Then data distribution in the column. As we already learned, column with many repeating values can be better compressed than one containing frequently changing values, because as we also demonstrate, run length encoding can be applied on top of hash encoding. Next is number of rows in the table, and finally column data type, which impacts only dictionary size. Okay, few more concepts that are important to understand before we jump into a demo. Once the DEX query has been generated by the formula engine, storage engine enters the stage and starts its physical work to satisfy the request. And relationships play a big part in this process. Basically, relationships enable quicker transfer of the filter context between related tables. And the most important thing to keep in mind regarding relationships is the higher the cardinality of the column that makes part of the relationship, the higher cost of that relationship is. So when the cardinality of the relationship exceeds 1 million, users can notice lower performance in the report. So if you identify relationships within your data model that have cardinality above 1 million, maybe you should start thinking of possible ways to optimize this. One of the reasonable solutions could be creating pre-aggregated tables with different levels of granularity, so you avoid expensive relationships at the query time. Another important concept for data model size optimization is aggregations. Aggregations are nothing more than reorganized versions of the source table. So you can have multiple different tables related to the same original table. What's the idea? By pre-aggregating data on different levels of granularity, we can help the storage engine to work faster and scan the data in a more efficient way. Applying different aggregations, in the end, we are reducing the amount of data, basically reducing the number of rows and columns. And if you take a look at this example, my raw table contains 7,346 records for chats between July 9th and 10th, 2017. Now, if I go and pre-aggregate data and count number of chats per specific subject, my aggregated table will only have 45 rows. So if my users need to analyze data per date and or chat subject, having this kind of prepared table will make the storage engine's job much easier, and it can retrieve the data much faster. One important thing to keep in mind regarding aggregations, they don't have any impact on the optimization of the complex DEX calculations. So they are just enabling the storage engine to work more efficiently and reduce the time needed to execute the queries. Also important to keep in mind, aggregations work only with native columns from your data model. In other words, you can't perform aggregations on calculated columns. In reality, you don't need to apply aggregations on each fact table, of course. Aggregations, Vertipack will work fast in most cases, and aggregations make sense with Vertipack only for extremely large tables, for example, a few 100 million rows or a few billion rows. And finally, be careful when creating aggregations, as each mistake can prove costly, because if not defined in a proper way, aggregations will produce incorrect results in the report. And keep in mind that correct results are the rule number one when creating reports. Then if you have correct results, you can spend some time trying to optimize this, but correctness is the requirement number one. Okay, so I believe we laid a solid theoretical background for the things that will come now. And it's time to get our hands dirty, as I promised, and see how all of this work in reality. So let me switch to Power BI Desktop. And this demo is based on a real use case which I faced during the last year. The problem was with the size of PBIX file on our report server, as file size has dramatically grown since the report had been introduced. So I was involved in trying to find a solution. Just to stress one thing before we proceed further, for this demo, I've created 4 separate PBIX files, each of them representing one single phase in the data model size optimization. I did that so we don't need to work on one single file and wait for Power BI to apply all changes we made during the process. As you probably know, in some cases, it takes a while to reload the data and recreate the data model. So let me show you the data model. I've just put I simplified it for this demo. So I have as a central table, I have fact chat table, which collects data about chats performed by customer support department. And I have just 2 dimensions, country and product. All the others were excluded from the model. And this fact table, let me show you. So this fact table has around 9.3 million rows. So nothing special in terms of volume. I mean, Power BI should be able to cope with that without any problems. But the main problem here is that all tables were imported in Power BI as it is without any additional optimization or transformation. So just simply choosing table name and import mode. So to be able to follow along what is going on with our data model, I will use DEX Studio. I guess you are familiar with this tool. If you're not, DEX Studio is a fantastic free tool created by Darren Gosbell, guy from Australia. It has a whole bunch of very handy and useful features that I would need another 60-minute session just to talk about it. In any case, if you're working with Power BI on a day-to-day basis, you should definitely start using DEX Studio. Believe me, it will make your life much easier. So let's launch DEX Studio directly from Power BI Desktop. If I go to external tools, I can launch DEX Studio directly from here. Of course, the prerequisite is to have it installed on the same machine as Power BI Desktop. And let's do a quick overview of the main features here in DEX Studio. So on the left side, you see all the tables from your data model. If you're confused and curious to know what this table with strange names represent, we will come later to explain this. And one of my favorite features in DEX Studio is Vertipack Analyzer tool. And Vertipack Analyzer tool will help us to see the numbers behind our data model. So basically what Vertipack Analyzer do, it just collects data from various dynamic management views. From tabular model, you can also use SQL Server Management Studio, for example, to query dynamic management views and get data about your data model. But you will probably find it in much more readable and structured way here in Vertipack Analyzer. Okay, so I will go here to Advanced tab and click on View Metrics. That will establish connection to my data model. And here I can see all the tables from my data model and different figures related to those tables. Let's just briefly walk through all of those columns here. So you can see the cardinality of the table size. Just to be clear, all of those numbers are in bytes. Data size, dictionary size, which encoding type Vertipack applied, and how much memory in terms of space each table occupies in your data model. Now, if I go and click on this small arrow next to a table name, I can see all these numbers broken down on a column level. So I can see all the columns from the table and how much space each of those columns occupies within the data model. One more thing, if we go to Summary tab, I'll do just this. You'll see that the total size of our data model is 1.86 gigs. I want you to remember this number. So 1.86 gigabyte. This is massive. This is really massive. Okay, so let's take a first look at our data model and see what we can do to optimize it. As I said, we can see the memory footprint for each of the columns here, and we can immediately spot which columns are the most expensive in our data model. So let's start examining one by one if we need to keep all of them in the data model. These two, chat ID is the surrogate key from data warehouse, while source ID is the natural key, primary key from the source system. In any case, I don't need both of them, so I'll go back to Power BI desktop and let's open Power Query Editor to transform the data. I'll go to fact chat table and let's get rid of source ID column. Okay, here it is. Remove. I'll hit close and apply, and let's wait for a few seconds for Power BI to apply those changes. It shouldn't take long. I'm always praying to demo gods when I'm doing live demos, so hopefully they will be on our side tonight. Okay, if I go again to my DAX Studio and again click on View Metrics, if I now go to Summary tab, you will see that now the size of data model is 1.54 gigabytes. So basically, by removing just one unnecessary column, we saved more than 300 megabytes. So let's go back and examine what else can be removed from the data model without taking a deeper look. And we will come later into this, I promise. Those two columns related to dates and times. We have date TM start, which is the original time zone when chat started, and this value converted to UTC. So in no scenario we need both of them, and each of them going to a second level of precision. As you may notice, each of those columns takes 454 megabytes. So just these two columns takes almost 1 gig of our data model, just two columns. So I will get rid of the original date TM start. Also, those two columns, referer and session referer, which are quite expensive because we have a cardinality higher than 1 million, and those are text data types. So you can see that both of them also occupies, one is 300 megabytes, one is more than 100 megabytes. And this is just a bunch of JSON records imported as it is. So it's completely useless for any kind of analysis within Power BI without further transformation. So I checked with my users and they don't perform any kind of analysis on these two columns. Also, last edit date, which is the information when the data was last time changed in data warehouse, completely useless for analysis in Power BI. Also, chat variables, again, bunch of JSON records imported as it is. So I will go back to Power BI and remove few of those columns. Let's go back to Power Query Editor. And let's remove those columns. Okay, let's go to fact chat. So I will remove date TM start. Then I'll remove referer. Date TM start referer, session referer. Oh, it's okay. Sometimes this control creates a confusion. Then also I'll remove what else we identified, last edit date, and also chat variables. I think that's it. Oh, stay here. Okay, I think I need to do it again. So date TM start, referer, session referer. Then last edit date, and finally chat variables. And let's go and remove those columns. Fine, hit close and apply, and let's again wait for a few moments for Power BI to apply those changes to our data model. Hopefully it will not take too long. And then we will switch again to DAX Studio to see the impact on the data model size. If there are any questions until we are waiting for this to execute, let me check in the chat window. Barcelona or PSG? I will answer first on this question. Barcelona, of course. I'm Messi fan, but I like Barcelona more than one player. Yeah, thanks Gina for kind words. Sinar asked, can we change sample data percentage for encoding selection to prevent wrong predictions for caching? Yes, you can use hints to instruct Vertipack which algorithm to use, but I strongly recommend against doing this. So avoid using this if you're not 100% sure what you are doing. Okay, so we are ready. I will come back to questions later. Let's go to DAX Studio again and click on View Metrics again. Now, if we go to Summary tab, you can see that our data model size is 660 megabytes. So basically, we shrank 2/3 of the size of our data model by just removing few unnecessary columns. And as I always like to say when I working on data model size optimization, checking which columns are unnecessary and unused in your report should always be your starting point when you're performing data model size optimization. Why? Let me show you example. We will quickly go back to a presentation. So let's imagine that you're preparing a delicious dinner for your friends and you invited them for a tasty pizza. But before you make the dish, you have to prepare the ingredients. So what goes into a regular pizza? Pizza bread, I don't know, tomato, sauce, ham, cheese. Maybe you need some extra ingredients for some of your guests, such as pineapple, I don't know, corn, egg, olives, because as a good host, you want to satisfy all your guests' needs. Okay, the next step, you're going to the local shop to buy all you need for your perfect pizza. But while you are walking through the shelves in the shop, you see a beer. Do you need a beer for pizza? I mean, it's always nice to have a beer, but do you need it for the pizza? Few steps more and you spot a chocolate ice cream. I like chocolate ice cream, I really do. But again, do I need it for my pizza? I mean, that would be really strange pizza with chocolate ice cream on it. So what's the moral of this pizza story? You should focus on those and only those things you really need. Translate it to your Power BI development. You should focus only on data your report users really need. You can put something extra, such as pineapples on top of our pizza, in some circumstances when you think that it would bring additional business value to your report or dashboard, but carefully evaluate if that brings more benefit in the final outcome. I mean, would you buy a whole pineapple and put it all over your big pizza if you have only one guest eating pineapple pizza and 5 others eat normal pizza? Or should you maybe prepare smaller pizza for this one pineapple guest without disrupting the main dish? And I believe that it's always useful to keep in mind this pizza comparison when you are considering which data to put in your data model. So going back to DAX Studio, truth to be said, in our data model, there are a few more columns that could be dismissed, but let's now focus on other techniques for data model optimization. As you may recall from the previous part of our session, when I was emphasizing the order of importance of parameters that affects the model size, I mentioned that cardinality is number one. So number of distinct values within the column. The rule of thumb is the higher the cardinality of a column, so the more distinct values in it, it's harder for Vertipack to optimally compress your data, especially if we are not working with integer values. There are multiple techniques for reducing the column cardinality, and the most popular one is column splitting. And I'll share with you now a few examples of using this technique. Okay, so basically, those optimization techniques must be performed on the source side, in most cases by writing a T-SQL statement or within the Power Query editor. Of course, keep in mind if you're writing custom T-SQL code to import the data to your Power BI data model, don't forget that you should perform all necessary transformations within your T-SQL logic, as the query folding would be broken if you use custom T-SQL and afterward apply additional transformation steps in Power Query editor. Okay, so as you can see, I hope you can see, let me zoom it a little bit. For integer columns, you can split them into two even columns using division and modulo operations. In our case, it would be something like this. So basically, we are getting two columns, one with lower cardinality and one with cardinality same as in the original column, but we are saving some bytes in this column because we have only 3 digits instead of 7. Similar thing for decimal values. You can split the values between before and after the decimal point. That's also reducing the cardinality. And also for date time columns, if you need to keep time portion if you're in your report, you can use this technique to simply split date part in one column and then put time portion in the other one. That will also reduce the cardinality of your column. Of course, these techniques would require additional effort in the report itself and rewriting your measures to return correct results. So be careful when to use them. We will examine this in the closing part of the session. I just want you to be aware that these techniques exist and can bring significant benefits in specific scenarios. Okay, so since we don't have any decimal values, let's focus on our exact problem, and that is optimizing this date team start UTC column. There are multiple valid options to optimize this column. The first, of course, the easiest one is to check if your users need granularity higher than the day level. In other words, can we remove hours, minutes, and seconds from our data? Lower granularity, sorry, not higher. Apologize for this. Without talking to my users, I was examining what kind of savings would that bring to my solution, and this is what I done here. So basically, let me show you in Power Query. I just removed time portion from my date team start UTC column. So I changed type from date time to date. And if I now go to external tools and connect this PBX file to DAX Studio, let me check what kind of savings this brings. I'll open advanced view metrics and let's go to a summary tab. 230 megabytes instead of 1.86 gigs. So it's approximately 15% from what we started from. Now Vertipack Analyzer shows me that my date team start UTC column is almost perfectly optimized, because we have, instead of almost 9 million rows, 9 million distinct values, we have slightly more than 1,000. Okay, so one big mistake I made here is that I haven't talked to my users before I did this, and it appeared that day level grain was not fine enough, and my users needed to analyze figures on hour level. That's also fine, as we can get rid of minutes and seconds here. that will also reduce the cardinality of columns. How do you do this? So I wrote this simple T-SQL query. Basically, the idea here is to round all the chats that started between 30000 and 35959 to starting hour, so to 30000. That's the idea, and that's the query I was using in the third PBIX file. And if I go to DAX Studio from this version, so when we have values rounded to hour level, advanced view metrics, and let's now check in summary. 221 megabytes. So basically 8 megabytes more than in the previous case, but we satisfied our users' needs. That's the most important thing. And the ATM start UTC column is still very nice, optimized with 32,000 distinct values. That's nothing special. And one thing here still bothered me, and this is this column chat ID, which is the surrogate key from the data warehouse, basically, and it occupies almost 1/3 of our table and our data model, our whole data model. Just to be clear, and I don't want you to come to some quick and incorrect conclusions, we can't simply go and remove all ID columns from the data model. Some of them, such as let me just zoom it, IP address ID, customer ID, product ID, those are foreign keys to our dimension tables, and therefore they are part of the relationships in our data model. So they can't be removed from here. But the chat ID column, as I said, is just a surrogate key, is not being used in any relationship or calculation. So in the end, I've asked myself if there would be any benefit if I keep the chat ID column at all. And I removed it from the model. This is the final version of PBIX without chat ID column. And if I connect to DAX Studio from this PBIX file, going to advanced view metrics and summary, 161 megabytes. I just want you to recall the number where we started, 1.86 gigs, and now we are at 161 megabytes. So that's astonishing. And I didn't lie to you when I said that I managed to reduce my data model size by 90%. If you compare our starting point, which was 1.86 gigs with current 161 megabytes, I'll let you do the math. And one last step to do is to disable auto date time options for data loading. If you're not aware, when you leave auto date time option checked, it will create a hidden table for every single date field in your data model. So if you have multiple date fields in a table of hundreds of millions or even billion rows, your data model will be bloated with those hidden date tables. And what's even worse, these tables search for the minimum and maximum date value in your column and create a date range that spans between minimum and maximum value. So if it happens that you have something like December 31st, 2099 for the current records, those automatically created date table will span until that date, even if you don't have any record in your fact table that matches that date. Of course, working with dates and importance of having a proper date dimension to handle all of your time intelligence calculations is a topic for separate session. But I just wanted to give you a quick heads up why you should consider disabling auto date time for your Power BI desktop files. And this is another hand use case of DAX Studio. As you already seen here, those tables, those are hidden date tables. You can't see them in Power BI desktop. You can see them only in DAX Studio. So if I go to File and Options and Settings, to Options, and if I go to Data Load, I will disable Auto Date Time. Click OK. Fine. If we go back to DAX Studio, those tables disappeared. So I will refresh this, and 4 megabytes, additional 4 megabytes saved using this. Fine. So maybe some of you now think, wait, Nikola, why did you waste our time with all this blah blah talk about Vertipack, encoding types, cardinality, stuff like that. What you have just shown us is basically removal of unnecessary columns, nothing special. And you are, I must admit, you are not completely, but almost completely right. However, in 95% of cases, when you are performing data model size optimization, simple removal of unnecessary and unused columns will be enough to get the job done, believe me. And as I already stressed, but it's never enough repeating this, that should be always your starting point when dealing with data model size optimization. In the remaining 5% of scenarios, you would maybe need to apply some more advanced approaches, such as cardinality reduction, using some of those techniques I've shown you a few minutes ago. Okay, so fine, let's wrap it up. And here is the list of general rules you should keep in mind when trying to reduce the data model size. First, again, keep only those columns your users need in the report, and just sticking with this one single rule will save you an unbelievable amount of space, I assure you. As you've just seen in our demo, sticking with this one rule helped us to make astonishing savings. Always remember pizza comparison. Next, try to optimize column cardinality whenever possible. There is no golden rule here. Golden rule here is test, test, test. And if you notice a significant benefit for example, splitting one column into two, or substituting decimal column with two whole number columns, then do it. But also keep in mind that your measures need to be rewritten to handle those structural changes in order to display expected results. So if your table is not so big, or if you have to rewrite hundreds of measures, maybe it's not worth splitting the column. As I said, it depends on your specific scenario, and you should carefully evaluate which solution makes more sense. Same as for columns, keep only those rows you need. For example, maybe you don't need to import data from the last 5 years, only 3. That will also reduce your data model size. Again, talk to your users, ask them what they really need before blindly drop everything inside your data model. Next, aggregate your data whenever possible. When you do aggregation, that means fewer rows, lower cardinality, so all those nice things we are trying to achieve. If you don't need hours, minutes, or seconds level of granularity, don't import them. Aggregations in Power BI and generally in tabular model are a very important and wide topic, which is of course out of the scope of this session, but there are some really awesome resources on the web, and I strongly recommend reading a blog series on creative aggregations from Phil Simark on dex.tips. Next, avoid using calculated columns whenever possible. Simply said, they are not optimally compressed. Instead, if you need to do some calculations, try to push them to a data source like SQL database, for example, or perform them using Power Query Editor. Next, use proper data types. Again, if your data granularity is on a day level, there is really no need to use date-time data type for your columns. In those situations, plain date data type will be completely fine. And finally, disable auto date time option for data loading. As you saw, this will remove a bunch of automatically created date tables in the background that bloat your data model. So that's it from me. I'm looking forward to hearing your questions, and hopefully that we'll have enough time to answer all of them. If you don't have enough time, or if I don't know the answer, I'll try to collect the questions and get back with the answers.
Well, there are several questions here.
Okay, let me just quickly walk through the chat window. Okay, star schema is recommended for Power BI, but let's say we have one big and wide table for analytics workloads. Do we still need to convert flat and wide table to star schema data model for better performance? As a question by Sinar. Yes, always try to build a star schema. That's the most desired data modeling concept for Power BI, and Power BI works best with star schema. So whenever you can, build a star schema. Create measures in Power Query or in the fields. I give a question by Tobar. I guess this in the fields means create measures in DAX or columns. You can't create measures in Power Query. the golden rule here is just to cut the story short. The golden rule here is whatever transformation or calculation you have to apply, try to push it as close to a data source as possible. So first try to perform it on a SQL database side, either in table, view, materialized view. Next stop is Power Query, and finally DAX for calculated columns. So we are not talking about measures, just to be clear. Okay, Gina already answered the questions. Question for star schema. Thanks for that. Yes, Marco and Alberto, they have a video explaining why star schema is the preferred type for Power BI. Is there a benefit in using integer keys instead of converting them to text? I do that often to prevent implicit measures. Also, is it a good idea to replace original keys coming from source database to integer surrogate keys? It depends. If you have original keys coming from source database that are not of integer data type, of course, it's a good idea. It's always good to have integer for your key columns because they are consuming less space than text. That's the general rule. Can auto-date time also be disabled in Power Pivot? As far as I know, it can't. So you can only disable it within the Power BI desktop itself, within the options. You can also disable it for all the reports, so you don't need to go every time you create a new PBIX file. Let me just quickly show you. If we have time, we have a few more minutes. So before Anna jumped in, so if you go to options and settings and options, in demo, I did it just for this PBIX file in current file, but you also can do on global options data load. You can also disable here auto date time, which is disabled for me by default. Okay, what is the benefit of use PBI DS? I'm not sure I understand the question. What is the benefit of use PBI DS if Dobar can just put some additional explanation? I guess he means Power BI data set. I'll try to answer assuming that it's Power BI data set. So it's reusability. Basically, you can publish a data set and then multiple reports can connect and reuse this data set. Can use some PBX files as a layer and after that build the model with graphs. What's the model with graphs?
Yeah, I think that he means like
Visualizations.
With the old access databases where you have one database that's truly just the database layer and one is the visualization layer. That's what I'm thinking he means.
Yeah. Yeah. So if you use PBI, yeah, you can use PBIX to build like a data model, publish this as a data. Exactly. Yeah. Okay. Yeah. Thanks for clarification. So you can publish this as a data set, and then other reports can use this data set as a source for visualizing data and for extending on this.
Awesome. As always, great questions.
Yeah, great questions. Thanks for the great questions.
And thank you, Nikola, for this awesome presentation. I know I learned a few things about Power BI, and I've been dealing with it for 5 years now, so it's all good.
Yeah. I mean, yeah, we are always learning.
Amen. You never stop learning because it's always changing.
Of course, especially in Power BI.
Yes, because you give Power BI about 10 minutes and it will update. So yeah.
Exactly.
One final question from Stobar. Is what he was suggesting optimal?
The only correct answer, it depends. So it depends on many different things. It's not yes or no. So if you plan to expose this data set to a self-service users, then it's a good idea. So basically, because you can control this intermediate layer, and no one can change measure definitions, stuff like that. So they are just live connected to this data set. In those scenarios, that's optimal solution. But if you don't have, I don't know, many users, I don't know, it depends on specific scenario, really.
Right, like everything else, you need to know the very specific usability of the users, how good they are with using Power BI. If you're embedded, that takes a few things out. There's all kinds of different scenarios you can play with on that one.
Exactly.
So Tobar, hopefully you understand now. The answer is it depends, just like everything else.
Yeah. One more thing before I leave, please, I kindly ask you for a feedback. It's important to us and to organizers, and don't forget to rate and review the sessions. And yeah.
You took